Hello, math humans. We're going to do 5.4b today. We're going to be doing integrals of exponential functions. So we're going to integrate those exponential functions, and there's your rule. Woohoo! All done. Yeah, math. So let's just do some examples. So we got to love e to the x because the derivative and the integral are the same thing. So if I want to do the integral of e to the 3x plus 1 dx, I have to do u substitution because I don't have a chain rule for integration. So I'm going to let u equal 3 to the x plus 1. So my du is 3 dx. So we need to introduce a 3. So my integral is going to become 1/3 the integral of e to the u du, which is just 1/3 e to the u plus c. So my integral of f of x dx is going to equal 1/3 e to the 3x plus 1 plus c. Pretty doggone straightforward. Woohoo! Example number 2. I'm going to have the integral of 5x e to the negative x squared dx. So again, I'm going to need to do some u substitution. I'm going to move this out before I start, so I'm going to write this as 5 integral x e to the negative x squared dx. I'm going to let my u equal a negative x squared, so my du is a negative 2x dx. I have the x dx, I need the negative 2, so that means I'm going to introduce a negative 1/2 to go with the 5 that's already out there, and then it becomes the integral of e to the u du. So this is a negative 5/2 e to the u plus c, and this is a negative 5/2 e to the negative x squared plus c. So my integral of f of x dx is going to be my little handy-dandy solution. So integrating e things is actually very nice, just like taking the derivative of e things. Okay? My next example, example number 3, is a little bit more entertaining. I'm going to have the integral of e to the 1 over x divided by x squared dx. Okay? So again, I'm going to rewrite this as the integral of e to the negative 1 over x squared dx. So my u is going to equal x to the negative 1. My du is a negative 1 x to the negative 2 dx, which is, here's my x to the negative 2 dx. So the negative 1 is the only thing that I need to introduce. So I'm going to have a negative integral e to the u du, which is just a negative e to the u plus c, which is a negative e to the 1 over x plus c. Okay, and then I would report my answers well, which means I would say the integral of f of x dx is equal to a negative e to the 1 over x plus c. All right, the next example that I have for us, example number 4. So example 4, I'm going to have the integral, I'm going to have a definite integral from negative 1 to 0 of e to the x times the cosine of e to the x dx. So that one's a little bit trickier, but actually it's still really pretty easy. I'm going to let my u equal e to the x, so my du, woohoo, is e to the x dx. Well, there's my e to the x dx. I have everything that I need. I don't need to introduce anything. So I'm going to have the definite integral from negative 1 to 0 of the cosine of u du. And so the integral of cosine is the sine of u evaluated from a negative 1 to 0. So this is going to be the sine of e to the x evaluated from a negative 1 to 0. Okay? So that's going to become the sine of e to the 0 minus the sine of e to the negative 1. Okay? E to the 0 is 1. And the sine of 1 is 0, okay? So then it's going to be, my solution is the sine of 1 over e. That's not a special, so I have to do that math in my grapher. I could have left it like this, But if I wanted to get a decimal approximation, then I would do 0.482. Remember that your grapher needs to be in radians, and then we would report well, so the integral from -1 to 0 of f of x dx is equal to the negative sign of 1 over e, or it's equal to 0.482. Your choice, okay? All right, there are lots of different ways you could do these problems, but sometimes it's kind of 6 of one, half a dozen of another. So there you go. Really short video today. You lucky dogs, less than 6 minutes. I'll see you soon.